Hello and welcome to the day 6 lecture here today for Upward Bound Advanced Math, our cryptology stuff. Today we're going to be looking at what we call Vigenere ciphers, which are a different type of cipher that we haven't really looked at yet. We've looked at things like Caesar ciphers and keyword ciphers and some other kind of random ones at the start for sure. And this one's a little bit different because those ones are considered to be monoalphabetic, just to kind of break that down a little bit. The other ones that we've talked about are monoalphabetic, which alphabetic, kind of looking at the word alphabet, and mono meaning one. A Vigenere cipher is what we call polyalphabetic. Meaning many alphabets, so to speak. And so just kind of looking at that, meaning that what it's going to eventually mean is some special things about some of the letters. And the idea of it using many alphabets, I'll break that down in just a second. But looking at this ciphertext message, there's a couple things that stand out. Definitely a couple things that stand out. First of which, I look at this word right here. Okay, this may not be the first thing that jumps out as weird to me, but this one seems a little bit weird in that I have a double J, a double X, and another double X. Okay, that to us is relatively strange. Okay. Not necessarily which letters are doubled, but that we have so many doubles, and then we have a repeating double letter in there. Okay, that's kind of weird. The next thing, as I just kind of look through it and peruse through it, and of course I've already seen it, so I know what's weird. A two-letter word with the repeated letter. We don't typically see that in English. Okay. Then as I continue looking, I see a triple letter in a 5-letter word. That actually happens again just a little bit later right there. Okay, where I have the GGG and the WWW. Unless that's a URL, a website, it would be a little bit weird. Same thing kind of here. I've got the double B's again, and I also have them one more time down here. So I have a lot of double B's in there, and that seems a little bit odd. Some other things that are a little less obvious. If I look at my one-letter words, this is odd. I have a P, an N, and 2 E's. That's odd. We wouldn't expect to see that in English to have 3 different one-letter words. Okay, so that right there, I'm not really getting at much of. I don't want to crack this right now. That's not really my focus. Oops. My focus is just noticing some weird things. And then if I look at the letter frequency analysis, there's some other weird things also. I have multiple that actually have the same percentages, which is really weird. We don't typically see that. We'll see a lot in the standard letter frequency conversation from last time. Let me just backtrack to that really quick. We'll see a couple like in the 6% ranges, and N, S, and H, and R are all kind of in the 6 range. There's a couple 2.4s and a couple 2.8s. And that's just in traditional English text. These are the percentages. But rarely do we see, we don't see multiples at the 8% range, but this one does have it. So I don't think we'll use that too much, but that's just, this breakdown, this frequency analysis. I just typed it in to basically a letter counter and let it run it for me. But we do notice that G and X are the most common, followed by I and W. R and T And then I have a lot of, I have kind of the same number of A's, B's, and P's. So that's kind of interesting. So again, just looking at it, but this is a Vigenere cipher, okay, or this was encrypted using a Vigenere cipher. So let's look at what that means. A Vigenere cipher is a polyalphabetic substitution cipher. So it's still substituting one letter for another, but that one letter doesn't always go to the same plain text letter, if that makes sense. Or I guess an easier way to think of that is that I can get the letter A in multiple different ways. Okay, so here's how it works. The Vigenere cipher comes with a keyword, and that's it. And obviously plain text or ciphertext. And so step one is to, and this is an encryption problem. So I'm going to be treating it like that. So an encryption problem. And so step one is to repeatedly write the keyword above the letters of my plain text or ciphertext, whichever one. Now, how it works is the interesting part. And in fact, I'm going to grab a cipher wheel just to help us out a little bit. I'd like it not to be full screen, so I can still see a little bit of what I'm doing. Okay, so this just, I looked up an online cipher wheel, lets me drag one wheel while the other one stays perfectly still. And I guess if we were looking at no shift, it would be right there. As fun as that is. And so I kind of have that first part done for us, though. Actually, let me do this. This will be a little bit better if I half and half this. And I'm going to do, nope, yep, that worked. A little more than half and half. Okay, now it won't like switch screens completely, and I'll be able to go back and forth. But anyway, step one, which I've done for us already, is to write the keyword letter by letter over the letters that we want to encrypt. Okay. Now, part of this is really boring, and I apologize for that, but it's a good way to kind of get warmed up to it. Everything that is under an S, okay, let me highlight those. Everything that is under an S gets encrypted with an S to A cipher wheel or an A to S cipher wheel, whichever way you'd like to think of that. Okay. And so we have to know how to encrypt with an A to S cipher wheel. So I'm going to turn A's into S's. Okay, that's what this means, is that a normal text, a plain text A, is going to turn into an S. There's obviously another way to do this too. You go to this S, put A on it. It doesn't really matter as long as you know which direction you're going. So for me, a plain text A is going to turn into a ciphertext S. Okay. Well, in this one, that's kind of boring because they're all A's under my S's, which kind of a sad thing, but it just means that all these are going to be S's. Okay. For the next one, let's move on to something a little bit more interesting. Everything that's under a P gets encrypted with an AP cipher wheel. So I want to turn this A into a P. So saying now that a plain text A turns into a cipher P. So in this case, all of these letters are getting adjusted differently. Okay, so a T, plain text T, is going to turn into an I. Plain text T is going to turn into an I, and then a plain text C is going to turn into an R. So I'm looking right here. A C turns into an R. And a W turns into an L. Okay. And then what's left over are all my Y's, all my things that are encrypted with a Y. And so if you notice the kind of method that I followed here was I went through and I encrypted all of my S letters, all of my P letters, and now all of my Y letters. And so for Y, I'm turning a T into an R. I turn a K into an I. I turn a D into a B, and I turn an N into an L. Okay, so really all this did was it combined 3 different Caesar ciphers and used one at a time, sort of every time. It switched it every time. So it's a trickier way as opposed to just a normal Caesar cipher. It results in, as we can see in the message up above, and even in this one here, it results in a lot of repeated letters in kind of a weird pattern that you wouldn't expect in any other type of Caesar cipher. Okay, and so this is a very important method of encrypting and decrypting. Let's look at a decrypting example. So I have this one here that's coded with keyword spy. So again, if I know the keyword life is good, I'm just going to repeat that up above, obviously skipping my spaces. We don't encrypt spaces, thankfully. There are types that do. There is a method of cryptology that makes you encrypt spaces or just doesn't put any spaces anywhere, making it a little bit harder. All right, so I'm going to go through and I'm going to decrypt this time, but the process is relatively the same. I just have to look at a different part of the wheel a little bit. Okay, so I'm using, for S, I'm using my A to S cipher wheel, and I want to decrypt a C. So for that decryption, I'm going from outside in. So C turns into K. So we have K. I'm going to keep going with my S's so that I don't have to switch the wheel every time. So now I want to find H. H turns into P. A on the outside turns into an I. W on the outside turns into E. And another W that's going to turn into an E. For the next one, I'm going to look at my A to P cipher wheel. And again, I'm looking outside in because I'm decrypting. T turns into an E. P, I turns into a T. H turns into an S. R turns into a C. And lastly, I, we already found that, turns into a T. Now, I think that you can kind of wheel of fortune this a little bit. I do agree with that, especially when we're decrypting. I think that you can play that game a little bit and try to guess what it is. I'll let you go ahead and guess. I'm going to keep going with the cipher wheel and make sure that that's what it is. Okay, so I've switched it to an A to Y cipher wheel, and I'm going to decrypt a C. So C turns into E. F turns into H. Q turns into S. And P turns into R. If you guessed keep this secret, then good job. All right. So that's one way to do it, is to use what we call a cipher wheel. It's a pretty good tool. It does have its drawbacks, though. I'm not gonna say that it doesn't. Its drawbacks really come from the fact that that I have to switch that wheel all the time. So sometimes instead what's used is what we call a Vigenere Square. Let me go ahead and full screen this really quick and go look at one on here. Oops, it's just on the next page. I'm used to having to scroll. So this is what we call a Vigenere Square. And all it is the letters A through Z and progressively shifted over one. So this creates all those different cipher wheels in one visualization. Okay, so looking at what we just did and kind of a way to showing you a way to use this. If I want to look at keyword spy and this CTCH, if I want to decrypt a C using an S shift, I go down to the S row, and in that S row, I'm looking for, it was C that I was looking for C, and looking at the plain text that's above C. Okay, and in this case, it was K. Okay, and I'm going to post this this Vigenere Square on the classroom. I think it's a good tool. I think it's almost easier than a cipher wheel. I do like having the plain text along the top. Remember, for us, anytime we have lowercase, that's our plain text, and capital is our ciphertext. So that can kind of keep you straight a little bit. Okay, so just looking at that, like I had that CTCH for SP and Y. So for the P, and I was looking for T, so I tracked the P row to T, and look what's at the top of that is an E, because our word went KEEP. And then for the Y, it's going to be tough because it's not really going to fit here. But Y, I track that over to C, and it's in the same column, so it's also an E. And then the last letter of that first word was, was S, or it was H. Made from S, which takes us to there, and that is a plain text P. So let's look at how we can use this. Okay, that's not what I had in mind. Great stuff. Trying to look at how we can use this square to kind of help us along with this. And I apologize if it's small. I don't really have any other way to show it all at the same time. So I guess I can drag this back and zoom this in just a little bit, because this just won't auto-fill, whereas this will. Okay, so I want to encrypt meet me tonight at midnight with the keyword cat. So step one is just going to be filling in my cat. C-A-T, C-A-T, C-A-T. And continue doing this. An important thing to notice is that it doesn't need to fill up the entire, or it doesn't need to end on a perfect cat, as these last two haven't. It just, whenever you run out is when you run out. So let's talk about how to encrypt using this. For an encryption using a Vigenere Square, I am going to, so let's start with my C, might as well. I'm going to go to my C row, and so that is this row. Okay, I go to my C row, and I want to find where the C and the M meet. So M is right here. They meet at an O. So that's the C row, the M column meet at O. So this is O. And I'm just going to continue with that C row. So I'm going to bounce around, because I'm not trying to make words here anyway, so going in order isn't that helpful. So I want to find out where C and T meet. C and T meet with a V. C and T meet with a V, same letter. C and I and C meet with a K. Where's that at? Right here. meet with a K. C and T, that's another V. C and M. C and M meet with an O. I already did that one. C and N meet with a P. And C and H meet with a J. Okay, some people like the Vigenere Square a lot better. Some people like to stick with the cipher wheel. It's totally up to you. One thing that's interesting is whenever we encrypt with an A, what does that do? The correct answer is nothing. Because when I encrypt anything with an A cipher wheel, an A to A cipher wheel, it doesn't change it at all, right? And some people think, well, that's just bad. That's bad taste. Like that's not really gonna confuse anybody because you're using the same letters that you would be using. And it's actually interesting that once we look at this, once it's completed, we'll notice like, well, yeah, sure, we threw that A in there, but it looks nothing like meet me tonight at midnight. And that's just part of it. Like at some point, there's only so much you can mix this up. And when you start throwing in the letters that they should be in the places they should be in, it's almost just as confusing. All right, so lastly, I'm going to look at my T row. And I want to find where T and E intersect. That's right here at X. Find out where T and E intersect. That's an X. T with N. It's kind of tough to look at. I can't really put my hands on there. That's a G. T and N. Is that what I said? T to N. I think that's an H actually. T. Nope, it's a G. Because I'm getting right here. Yeah. Then T with H is an A. So I have T to H is an A. Just trying to get creative here. Let's see. T with T. T with T up here is an M. T with D is a W. And T with G is a Z. So even though, I mean, one out of every three letters is the actual letter in the message because of the A in cat, it looks nothing like meet me tonight at midnight. We can kind of see some of those pieces, but that's only because we know what we're looking for. Okay. Let's see. I'm going to go ahead and let you try this one. Again, we're just decrypting with car. I will do the first sentence here, first three words, and then I'll let you do the rest. I do want to talk about one other thing before we leave. So, again, I'm not going to think too much with the A's. The A's are just going to turn into the letter that they are. L, Y, O, G. I should be writing lowercase, sorry. Let me fix those. So that's an L, that's a Y, that's an O, and that's a G. Okay, and then for my C, so using this Vigenere Square to decrypt, is a little bit tougher, but I want to start at my top row. I want to start with that for my setting which row I'm looking at. So on this first one is a C, so I'm looking at the C row and where the C is in that row and track that to the top. That one's kind of boring because it's C, and then this C tells me that I'm looking directly at this C. Look up, it's an A. And I have another one of those. I'm focusing on the C's. So C, C is A, C, C is A, C to F. So I'm looking in the C row, looking for F, and then look up is a D. C and K, C row, look for K, look up is an I. And then C row, look for the V, and look up is T. So that should be all my C's. Okay, now I'll look at the R row. R and N. So R, find N, and then look up is W. R with J, R to J, and then up is S. R with I. Remember, in the font that I use, any lines or I's, it will not give me an I like this. It's kind of stuck, just with the font that I use. So L's are capital L's. So R with I, sorry, I got sidetracked. That happens too much. R with I is, that's R. And then R with Y is H. So this statement starts off with always do right. Okay. And then, like I said, I'm going to let you finish the rest of it. Just remember, start off by putting, finishing out all the cars. Car, 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 car. And even though the sentence stopped, that doesn't mean that the keyword stops. So this would be A, R, C, A, R, all the way to the end. Okay. But I do want to talk about what it says at the bottom. So, cracking in class isn't really something that I want to always do. Because cracking ciphers is a pretty difficult task. It's a lot of work. It takes a lot of time, and often it takes a lot of guess and check. Okay, but with this type of a cipher, the important thing is figuring out that keyword, because we can't really do anything until we figure out the keyword. So if we look at what we started with today, and look at this message that can be decrypted. There's nothing saying that it can't. It can definitely be decrypted. Let me try to look at the whole thing. I'm going to go with maybe 150. Yeah, that lets me see it all. So this message can be decrypted, and it does work out to something that's coherent, at least. But we need to know, or we would like to know the keyword. If we knew the keyword, everything would work out fine. Decrypt it, just like we have a couple times already. Sure, it's a longer message, so it's just going to take more time. But there's actually a way that we can go at cracking a message like this. And there's a couple things that I want to look at that are going to help that out. So I notice a few things that are somewhat important. I notice that I have repeated words, and that's going to actually help me to find the length of the keyword. Okay, I see this word here and this word here as being repeated. Okay, and they're the same length word, same exact letters. And so I am taking a guess here, but I'm going to guess that those two words are the same. Now, for two words to be the same in this Vigenere cipher, whatever the keyword is, which we typically write above here, whatever it is, whatever this letter is in the keyword, this letter is the same. Well, what that means is if I count this off, that's a 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And then the numbering would start over. Okay, and it would keep going. Okay, well, I noticed that there. Now, 20 spaces away seems like a lot, right? So maybe, I mean, I can't think of many keywords that would be 20 letters. Of course, I could make them. Keywords don't have to just be words. They could be phrases as well. Well, let me look at this down here. I have the BB repeated, and these seem to be a little bit closer, but let me look. 6, 7, 8, 9, 10. This might be the same. 13, 14, 15. It is. 17, 18, 19, and 20. I was hoping that they would be closer together, but they're not. So I do see a common theme there. So I would say that my keyword has to possibly be 20. And that's kind of the biggest it can be. So it can't be any bigger than 20. 20 seems like a pretty good guess, but there are other options also. Because I could set up another numbering system that would start at 1 here and then restart at 1 here also. And it comes from factors of 20. Okay? So it comes from factors of 20. So that would be like numbers that multiply to give you 20. So it could be 2 and 5. So it could be 2 and 10. So either 2 or 10, 4 and 5. So it could be 4 or 5. And that's just talking about how long the keyword is. And the trick here is that at some point you just have to take a guess. Okay. I don't think the keyword is 20 letters long. I really don't. I don't even really think that it's 10 letters long. So that kind of leaves like 2, 4, and 5. I think it would be really boring if it was 2. So that kind of leaves 4 or 5. Well, at that point, you just want to take a leap. Take a leap of faith. Give something a try. Okay, I'm going to guess that it's 4. Also because I sat down and did it all. Now, again, I'm not going to ask you to actually crack this one. I do want to talk about kind of the next step, though. If we're going to guess that it's 4, and this is a guess, because at some point we have to guess and check. We don't know what the keyword is, and I'm going to say that we don't need to. But what I would do is I would write 1, 2, 3, 4 on all these. And then at some point, I'm going to get to a point where P, as a one-letter word P, has a 1, 2, 3, or 4. I don't want to count that far. I'm just going to guess that it's 3. And then maybe N is a 4 and E is a 2. Right? So at some point, I'm going to get those. And they're probably all different numbers. They get different Caesar ciphers associated with each one of them. From there, you're going to take a guess again. There's only 2 one-letter words in English, A or I, and from there you're gonna take a guess and give it a shot. Okay, so you're going to say, well, what happens if I let all of my 3s be ciphered with an A to P wheel? And you're going to look at all those and see what it comes up with, and see, you're going to have to, do that and then say, well, I'm going to let all my 4s be an A to N cipher wheel, and all my 2s be an A to E cipher wheel, or maybe an I to E cipher wheel. And you're going to take those guesses and fill in what that tells you. And it's frustrating. I spent a better part of my night last night trying to figure this one out. It's a guess and check game. It just is. There's ways to, make educated guesses, but it's a tough one. So again, I'm not going to ask you to do that. The one thing I will say is I had a lot of people that had a hard time on the previous day of cracking this message. Again, cracking is something that takes time. We don't know the shift. We don't know the keyword. We don't know whatever. I did give everybody a hint as to who was the one responsible for this quote, and this can help you. Now, keep in mind, this is not a Vigenere cipher. It is a keyword cipher where just in here somewhere there's a keyword, and then outside of that keyword it uses up all the letters that aren't in the keyword in order. Something like that. I don't know where it is. Don't quote me on this at all. But using what I gave you down there at the bottom, I think you can probably figure out the rest. But take your time. I do expect this to be done. I do not expect this to be done. Okay. If you want, kudos and bonus points and a thing where there are no points, you can go ahead and try this. It is the keyword is 4 letters long, so you can go with this idea. But then there's some guess and check that's involved. Okay, all right. So hopefully that helps. Make sure you get at least the problems that I left for you to do. Get those done. Otherwise, I hope you have a great day, and we will see you next time.